Hello, my name's Evan Sinisak. I'm recording this video demo for my Info 6022 Physics and Simulation 2 Project 1. I decided to build this project off of the Physics and Simulation 1 final program that we did. As such, there's a bit extra in here, and it's a bit messier than it needs to be, in particular with the configuration stuff. I've removed most of it, but at the same time I didn't want to completely break some stuff, and I want to keep stuff around so that for the future I could have both physics particle and rigid body stuff going on at the same time. If the project ends up being too big for Fanshawe Online, I will go through and clear stuff out, but for this demo, I'm just going to go through what I've added for the rigid body physics, and the other reason why I wanted to keep it around is because it's actually very similar to how I handled the particle physics in terms of keeping it updated and making entities. As you'll see in the animation demo and program, whenever we make new features and stuff, I like making new game objects or entities that have the new features attached to them so that I can test them in the world the way that I understanding know how to handle. So for the physics rigid body stuff, we're using the interface and physics world and factory that we made in class together. We made these external libraries, so they're included in the project so that I have access to them. And then the way that I handled incorporating them is I have a global physics world and a global physics factory, where the factory is basically used to make the specific rigid bodies that we need. Otherwise, can't have access to them, right? So, for this project, I make, before the main while loop, I go through and I make the 5 different rigid body spheres. Each sphere has a different size and mass. I decide to just do the mass as 10 times whatever the radius is. So the biggest sphere is going to have the biggest mass, and vice versa, the smallest sphere will have the smallest mass. And the first sphere I make, which will be in the center of the screen, is going to be our first selected sphere. And then I go through and I make the planes, basically creating a box with a floor, no ceiling, adding rigid bodies and creating the rigid body from the factory, and then adding the rigid body to each wall of the box. Then, after making all our rigid bodies, just a bunch of graphics stuff. Apparently I forgot to put a bookmark here for myself. Not that it'll matter once I delete the VS folder. Once each rigid body is made, it gets added to the physics world. So the first thing we have to do is run the time step on the physics body, on the rigid body world. and then go through the vector of entities and update the mesh positions. And then I have... Right, camera. I started making the camera follow the selected sphere, but then I got a bit lazy and it wasn't working how I wanted it to. So I just gave up on it and decided we're just going to focus on the center of the screen and handle the forces like that. So I'm going to have to clear these out as I go. Global things, I had to add a couple things. This had to make a global physics factory and a global physics world. I also decided to just have a pointer to a specific rigid body for whichever one is selected. And then for the way that I'm handling things, I have a vector of my entities, which I could have made rigid body entities because they're all entities. They're all the same entities in this program. But I guess I went with the base class and I dynamic cast whenever I need to. And then I have the selected entity index for which entity we're doing. And then I just have a vec4 for the not selected and selected color. Declaring them in global things.cpp so that they are global, with the factory and world being created in startup, which is here. So we make a new physics factory and then we use the physics factory to create the world. I started making the collision listener. I made the collision listener. I'll just show it real quick. It just takes the collision, checks that both rigid bodies that are passed in the collision are spheres, and if I wasn't being stubborn and lazy, I would have implemented fmod into this program, but instead I'm just printing out that the balls hit. So, yep, physics world is created by the factory, and then we register the collision listener, which is just a new collision listener, and we set the gravity of the world to negative 9.81. I think this collision handler... What did I change here? Oh, I changed... we were told after... This is the collision handler that we did in class. One of the calculations in sphere plane needed just a less than here. Change from less than equal to less than, so that if the rigid body starts resting on the plane, it doesn't disappear or freak out. I just decided that the spheres are going to start high up and bounce. Input. So, for this program, motion is determined by applied forces and the constant acceleration of gravity, with the exception of collision reactions. Integration scheme is velocity relay, or the equivalent fourth order method. That is how we made the system in class. Planes. There are planes enclosing the scene with the appropriate collision handling. Check. 5 individual spheres with different radius and mass, behaving as free rigid bodies. Correct. Reactions conserve momentum and evolve elastic and inelastic. They look right. We'll see that it works and looks right. And a single sphere is under control of the user and has distinct color to show it. Pressing number keys to decide which one is currently under control. WASD applies forces to the selected sphere, where forward, backward, left, and right are relative to the camera and orthogonal to the plane. aka not in world space. Realizing how I should have handled it, but the way I handled it, it still works the same. I'll explain what I mean by that in a second. Camera's at constant angle and points at the center of the scene or the sphere that is being controlled. I went with center of the scene so that I could keep the constant angle. Zoom in and out with up down arrows and rotate left right with right arrows. Set some reasonable max min. Yep. And like I said, I'm not doing the bonus. I just have it printing instead of making some sounds. So in input handling, this is where we apply, or where we can handle multiple keys being pressed at the same time and just holding a button down. So this isn't true anymore since WASD are not for the camera. So to figure out what the forward force orthogonal to the plane is, my ground plane or floor plane has the world 010 normal, and my camera has an up vector which is the same thing, 010. And neither of those ever change. So to find the forward component of the camera, I just take the X and Z component of camera forward. That is the other thing in global that I forgot to go over. How this camera works. So the way that my fly camera works is that I have the camera eye, the camera target, and the up vector. And the up vector is always 010. It never gets changed. The camera eye is the position in world space, and the camera target for the fly camera is the rotation and position to direct what the camera is looking at. However, that is no longer the case since I'm not using my fly camera. Instead, the camera target is the point in the world that we want to look for, and the camera forward is the normalized difference between the camera target and the camera eye. So right here, my camera target is the origin of the world, my up vector is 010, and my eye starts at 15, -30, and my camera forward is target minus camera eye. I did not normalize that. I believe I normalized that in main. Where do I update the camera? Yeah, so every frame the camera forward gets updated to camera target minus camera eye, and then camera forward gets normalized, and then we look at camera eye plus camera forward and the up vector, which again never changes. So here, camera forward is the direction from the camera eye to the camera target. So when I want the forward component of that, I just need the XZ 0Y, because we're just going to be pushing the ball forward. I then normalize these values, multiply it by my speed modifier, which is just a local value variable. I considered multiplying it by delta time, but I found that was unnecessary and made the forces too small. So it is just multiplied by 10. And then we get the rigid body off the pointer of the rigid body off the selected entity and apply the forward force to it. And the exact same thing for backwards. We just multiply it by -1 and then apply the force. For left, I found out when making the fly camera that in order to get the right vector, which this makes complete sense because that is exactly what the cross product is, you just take the cross product between your forward facing direction and your up vector. So if you think of it in terms of world axes, if I want to get my z-axis, then I can cross my x-axis with my y-axis, and that gives me a right angle to both, and it'll be pointing to the right. So first thing I do is I get my forward vector from the camera, then I normalize the cross product between the forward and up vector, and since A is left, I multiply it by -1, multiply it by my speed modifier, and then apply that force to this currently selected sphere, and do the same thing without reversing it to D to apply the right vector. Q and E aren't used. Zoom in towards the camera for the arrow key up. We just add the camera forward to the camera eye, and then check if the distance between camera eye and camera target are less than the minimum distance squared. Then we subtract that change again. And then the same thing for zoom out, except for greater than and max. And then right, like I said, just take the cross product between forward and the up vector and move the camera eye in that direction. And then because camera forward is being updated every frame in main, this causes the camera to just rotate around the origin, and then subtract from the camera eye for left. This is a bunch of old particle physics stuff, and I think that's it in input. Yep, that's all for input. Shut down, we delete all our global stuff. So here is my rigid body sphere entity, which actually I do need to go over. I don't know why I decided to handle it like this, but I made a rigid body in my main project that all it contains is a pointer to the iRigid body of our GDP physics library. I don't know. That's just what I made for some reason. So when I make this rigid body sphere entity, I use my rigid body, which just contains a pointer to the GDP physics rigid body. And when I make the rigid bodies, no, I know where I do it. So I have my rigid body sphere entity, has its main constructor, add to world, remove from world, which I'm going to implement because I don't know why I didn't. Update, and a pointer to its mesh, and a pointer to its rigid body, and then its radius and mass. I don't know why. Oh, I know why, because I made it global. Okay, I'm not using them. And I add them to the world in the constructor. So the constructor makes the mesh rather than making the mesh outside, since every single one is going to be a sphere with its radius, mass, and position set in the constructor when calling the constructor. Then we make the rigid body using the sphere shape and the sphere shape description. Give it some damping, tell it what its mass and position is, and then use the physics factory to create the rigid body using the sphere description and shape. Tell the pointer on the sphere entity for the rigid body that it's a new rigid body, and make the pointer point to the new GDP physics rigid body, which I guess I should do this just to make sure that they're all actually the same thing. Should still work. If it doesn't, I'll switch that back. And then in update, I get the position of the rigid body and set the position of the mesh to be the same. Shapes, I don't think I changed. Nope, I just have it open because I was checking how it worked. And I think that's everything I need to go over, because I didn't change any of the physics libraries that we made. I think this project... If I remember right, for some reason, for some reason in release, the physics interface doesn't build. It has this error, did you forget to include PCH to your source in shapes and SRC. So this program only runs in debug x64. So let's run it and look at the spheres. So as I said, the camera is only going to point at the origin. And rotate around it, and it will apply the forces to the different spheres in terms relative to the direction that it is facing from its position to the origin. So, like I said, I start them all a bit high so that they can just fall and bounce. And if I press the back arrow key and forward arrow key, the camera just zooms in and out. And so now, just to show, I'm going to press D, and the selected sphere starts moving right. There is a plane in the same place as the walls, as well as the floor plane. So I can just press left and right, A and D, and let's just get some speed on this ball. It's just bouncing back and forth. And now if I press W, it's going to start moving off that line. And if I hit the smaller ball, it goes bouncing off. I did find that because of if you're still holding a direction after hitting the small sphere, they kind of overwrite the collision forces. So if you want to see the collisions behave properly, you have to let go of the WASD keys before they actually collide, and then you can watch how the collision forces interact more normally. So if I press the right arrow key, I'm going to try and line it up with the ball, with the red ball. And if I press down, or if I press S, now the ball is going to start moving backwards towards the camera. I'm going to hit this other ball. And can't see it now because it's behind it. And if I move over here and press and hold W, and I can move over here and hit the other ball. So that's all that. And now, so the first sphere that's selected is 1. 2 is the big sphere. So if I start holding S and A, it starts moving very, very slowly. Uh, 3 is now the tiny sphere, which can build up some speed pretty quickly because of its low mass. Where'd it go? There it is. 4 is that sphere, 5 is this sphere. All of which you can apply forces to and move them around the scene. And I think that's all we really needed for this program. You can just have fun, send the balls around. I have not yet experienced the balls clipping out of the planes, other than when they were spawning on top of the plane or touching the plane and they would clip out, which I haven't actually tested them since changing that less than equal to, because I did want to show that gravity is being used here by having the spheres start above the plane and fall down and bounce and eventually come to rest. But yeah, I'm gonna clean up some stuff and submit this. Thank you for watching. Bye. Little spear, go!